Hey everybody, have you been wondering why this fish that lived in Lake Ontario is called the Atlantic salmon? Isn't the Atlantic an ocean or something? As we've learned in previous episodes, Atlantic salmon start out their lives in cold water streams, where they live the first 1 to 3 years of their lives. Then as smolts, they swim downstream to Lake Ontario, where they grow for another 1 to 3 years before returning back upstream to spawn. They don't just swim up any stream though. When the fish are young, they get to know their particular stream, which we call their natal stream, in a process called imprinting. Later, when it's time for these fish to spawn, in one of the many amazing feats of nature, they return to their natal stream. Of course, they don't always go back to their natal stream. If they did, we'd only ever find them in one stream. Sometimes they will stray into new rivers, streams, and lakes, and they'll find new suitable habitat to live in. Our Atlantic salmon will swim around the whole of Lake Ontario, and they may be hundreds of kilometers away from their natal stream. Atlantic salmon out in the ocean may have traveled thousands of kilometers away. When it's time for them to spawn, they turn around and they're able to find their way back. And they have no road signs, they have no Google Maps, but what they do have is this powerful nose. An Atlantic salmon's sense of smell is about 1,000 times better than that of a dog's. Each stream smells just a little bit different. By using a combination of the Earth's magnetic fields and their strong sense of smell, Atlantic salmon are able to find their way back to their natal stream. Us humans really are disadvantaged physically in a lot of ways compared to other animals. We don't have this amazing sense of smell like that of an Atlantic salmon or a moose. We don't have big claws like a bear or a tiger, or big teeth like a wolf, a shark, or a lion. We can't quickly climb a tree like a raccoon or a monkey, or a steep mountainside like a bighorn sheep. We can't run fast like a deer, a cheetah, or a hare, or fly away like an owl. We can't dive under the water and quickly swim away like a loon can. Nor do we have a thick coat to protect us from the extreme cold like a muskox does. So how have we survived? Well, some people believe it's because we have superior thinking abilities. But all you have to do is turn on the television, you'll see that that's not always true. I personally believe that our survival and our success as a species is due to our social bonds. We have the ability to take care of each other and to share resources, knowledge, and skills. This enables us to stay safe in the face of danger and to grow our understanding of the world around us. For hundreds of thousands of years, humans have been using the first form of social media. No, it's not Facebook or TikTok, it's firelight. People have gathered and still do gather around a fire and share stories. The art of storytelling is a hugely powerful tool for sharing information. The best hunting, fishing, and gathering locations, how to make tools, clothing, and shelter, and how best to avoid or deal with hazards. With writing, first on stone and then on paper, and now with video and audio recordings and the internet, we are able to share information at an incredibly fast rate. Scientific understanding has undoubtedly benefited from this knowledge sharing. We are able to build upon previous experiments, lessons learned, and evolving theories. We have the opportunity to not have to start over every single time. Instead, we can build upon what others have already learned and achieved. In this way, we can achieve much more than those who came before us. You can see much, much further if you stand on the shoulders of giants. In this week's episode, we're going to hear from the original giant of the Bring Back the Salmon program and the creator of our classroom hatchery program, Chris Robinson. Chris is going to be teaching us about the native range of Atlantic salmon and when and how they arrived into Lake Ontario. After Chris, we'll hear another fishy fact from Johnny. But before we get to that, let's check on our hatcheries. Checking on hatchery number 1. The filter and the air pump are working. The temperature is 3 degrees Celsius. Our Atlantic salmon are healthy-eyed eggs. Checking on hatchery number 2. First off, we have this foam floating on the top of the water. If I didn't know any better, I'd be concerned that something has gone wrong. It almost looks like someone dumped in a bunch of dish soap. But I do know better, because I've seen this before, and I know that this is the outer part of the eggs, known as membranes. There's only one event that will cause the membranes to float to the surface, and that is, our fish have hatched. We can now clearly see their heads, tails, and yolk sacs. We now have Alvin in hatchery number 2. They are very fragile at this stage. In the wild, they would be staying still in the protection of the red, growing from the nutrition in their yolk. We'll leave them for at least another 2 weeks before we release them from the condo into the rest of the tank. You can also see that there are some eggs that have turned snow white. These eggs have died. This is normal and happens in the natural environment as well. Some eggs just are not designed for survival. We can't let the excitement of our hatching event make us forget to make sure the rest of the equipment is functioning properly. So let's check the regular stuff. The filter and air pump are running, and our temperature is 7 degrees Celsius. Things are great with our hatcheries. Now we'll hear from our presenters.
Hello, my name is Chris Robinson, and I work for the Ontario Federation of Anglers and Hunters, where I'm the Fish and Wildlife Conservation Programs Manager. I work with the teams that deliver the Lake Ontario Atlantic Salmon Restoration Program, the Invading Species Awareness Program, and the Community Hatchery Program. That last program works with hatcheries that are sort of like the ones you're learning about from Ben, but are much bigger. They fill whole buildings, and they're run by volunteers, and they produce millions of fish for Ontario's lakes and rivers each year. I also worked with the person who runs our program called Alice Peterborough. It's a bit of a strange name. It's not Alice like the name, but it's ALUS, and that stands for Alternative Land Use Services, which works with farmers who have some land that maybe isn't that valuable for farming, but could be very valuable for fish and wildlife, and it works to make that land better habitat for our fish and wildlife species. So the OFH overall works on a lot of things that are trying to help our fish and wildlife populations across Ontario. You're learning about many of those things specific to Atlantic salmon and Lake Ontario from Ben and his other guests. But the OFH does things like habitat restoration, running fish hatcheries to help restore or sustain our fisheries, and it also works to keep things like invading species that are harmful to our land and our water out of the province as much as we can. But I'm here today to talk about my old job. I used to run the Lake Ontario Atlantic Salmon Restoration Program for over 10 years. And because I'm so old, Ben has asked me to come in today to talk a bit about Atlantic salmon around the world, where they are, their history around the world, and also why they're so important to the history of Ontario as well.
So Atlantic salmon get their name, as you might imagine, because almost all of them live their adult lives somewhere in the Atlantic Ocean. This map shows where they're generally found in the Atlantic and connects them back to where their home streams are, where they go to lay their eggs and where the young fish live before they're ready for the ocean. You can see over in Europe, their home streams can be as far south as Portugal, or all the way up to northern Russia. Here in North America, they're in rivers along the eastern coast of Canada and the United States. The European Atlantic salmon usually go live in the North Sea area as adults, but some of them travel across the ocean and hang out with their North American fish between Greenland and Labrador. Iceland is an important Atlantic salmon home, and there the first known laws protecting them were made over 1,000 years ago. Back then, Iceland had one of the first parliaments called the Althing, and because they didn't have writing, all of their laws were memorized and passed down by an oral tradition. In other words, by speaking them out loud so everyone could hear them. About 300 years later, writing came to Iceland, and the laws were written down then. Although Iceland has had laws protecting Atlantic salmon for over 1,000 years, in fact, in Europe, people have had an even longer history with Atlantic salmon. This is a cave carving of a salmon from France, and it was made about 25,000 years ago during the last ice age. Even back then, Atlantic salmon were important to people as a source of food and possibly worship, and they made this carving to commemorate them. You can see it's a pretty good image of an Atlantic salmon. They even got the adipose fin that Ben talked about in episode 1 correct. Younger than that carving, but still pretty old, is this Celtic or Pictish carving from Scotland, made about 2,500 years ago. Atlantic salmon were, again, an important source of food for the Celts. They were part of their culture, too. One of the tests their warriors had to pass was called the salmon leap, which tested how high he could jump, just like an Atlantic salmon jumping over a waterfall. Atlantic salmon are still important around the world today as a food fish, though almost all of the Atlantic salmon you'll see in a grocery store or on a restaurant menu are from farmed fish that live in pens or ponds. That's because almost everywhere they live, Atlantic salmon are in a lot of trouble, and that ties into what you're learning from Ben in these videos, because you'll also see that Lake Ontario doesn't have any dark blue on it, but it once did. As the last ice age was coming to an end, the glaciers, which were once a few thousand meters thick, were melting and retreating north, leaving behind what became Lake Ontario, as well as the rest of the landscape we have today. But what they first left behind was a much bigger lake, what we call Lake Iroquois, that later shrank down into our modern Lake Ontario. You can see how the shores of today's Lake Ontario were mostly under the waters of that Lake Iroquois. Many of you living around Lake Ontario will probably see that where you live was once the bottom of that lake. Lake Iroquois was connected to the Atlantic Ocean through a river that doesn't exist anymore, and about 12,000 years ago, Atlantic salmon found that river, swam up it, and adapted to life in Lake Ontario, spending their adult lives in the freshwater lake, and then using its many rivers, particularly those on the north shore of the lake, to lay their eggs in and for the young fish to live in. Over the centuries, Lake Iroquois settled down to become our modern Lake Ontario, but those Atlantic salmon stayed. And all around Lake Ontario, Atlantic salmon were an important source of food and an object of worship to the First Nations peoples here. As Europeans arrived in the area, they found Atlantic salmon too, and on the screen I have the first written report of Atlantic salmon. It was made by some Jesuit missionaries and their men who caught some and probably had them for dinner about 350 years ago. As more pioneers came and they began to establish their farms, they still needed some food that they could rely on to survive over the winters. So they would go into the rivers and catch Atlantic salmon. There were a lot of them. They were easy to catch, and they would smoke or salt the Atlantic salmon for the winter and survive off of them. The pioneers also had a lot of stories about Atlantic salmon, that you could walk across the river in the fall and your feet wouldn't get wet because you could just walk across the bats of all the fish in the river. They also said it was dangerous to take your horse into the river because it would get scared by all the Atlantic salmon swimming around and bumping into its legs and it might run away on you. They also told a story that a couple of men were filling a small boat that was perched up on a log, and they were filling it with salmon they were catching and pitchforking into the boat, and they weren't paying attention to how many they were catching, and eventually they filled the boat so full it just broke in half. With that long, long history with Atlantic salmon from back in Europe, the pioneers who settled around the shores of Lake Ontario considered what they found here to be the greatest freshwater population of the species in the world. There were at least 40 streams that they used to reproduce in, to lay their eggs in, for the young fish to live in. Some places had so many Atlantic salmon they were actually named after the salmon. The town of Salmonville is actually the village of Terracotta now, up near Orangeville, and the town of Cobourg used to be known as Salmon City just over 200 years ago. We sent eggs from Lake Ontario to New Zealand and Argentina to try to create populations of Atlantic salmon there. We also sent them back to Europe to try to save some populations that were in trouble. People thought our population here was so great that it would help over there too. We had some very early laws trying to protect our Atlantic salmon, and particularly when they were running into the rivers. But despite those laws protecting them, despite them being very important to people, despite there being so many of them, we soon lost our Atlantic salmon. You'll be learning more about what happened to Ontario's Atlantic salmon in other episodes, so this is where I'll wrap up my chat about Atlantic salmon history. Now that I've talked about Atlantic salmon, Ben asked me to talk for a bit about me and the paths I took to become a biologist and conservationist. Starting sometime around grade 5, when I realized I was not going to play in the NHL or the CFL or the NBA or Major League Baseball or even professional bowling, I decided I wanted to get into conservation and biology. Around that time, I also started reading books by a famous British conservationist named Gerald Durrell. Many of his books had been turned into TV shows that were on CBC or TVO or PBS, and this all helped give me some ideas on what to do and what to study, and got me even more interested in conservation. Besides telling you some amazing and sometimes sad conservation stories, these books are also very funny, and they're also easy to read. So if you're interested in conservation and they're maybe in grade 5 or older, I'll ask Ben to include the link that I have here to Gerald Durrell's Wikipedia page so you can find out more information about him and what he wrote. This all kept me very focused on science and math in high school, and after I graduated from there, I went to the University of Guelph for a degree in zoology. There were a lot of cool courses to take at Guelph. Back then, there were seals on the campus. We got to study everything from rats to lobsters to even playing music to mealworms to see which direction they'd move in. One of the most important courses I took there, though, was a writing course. I expect some of you might be surprised to learn that for a job in science and conservation, being able to write well is one of the most important skills you can have, but it is. It's important for a lot of jobs, but writing well has gotten me more jobs than just how good I was at science. When I first came out of university, I started working for the Ministry of Natural Resources and Forestry in Ontario, and I was working with one of their scientists at a fishery station on Lake Ontario. We worked on a lot of things, but we specialized in taking parts of fish, scales, fins, bones from their brains and shoulders, and using those like tree rings to figure out how old fish were and how fast they grew. You can look at age and growth and then compare them to water temperature or how much food was around or how much fishing was going on to learn how fish respond to their environment. While I was doing that, I started on another level of education, a master's degree. This is sort of like a dedicated science project that you spend a couple of years working on. Here's what mine looked like when it was done. My project was on a type of fish called the muskellunge, also known as the water wolf and the tiger of the lakes. It's one of the largest freshwater fish we have in North America. I had bones from muskellunge from all over, mainly Wisconsin and Ontario though. And the particular bone I worked on was sent in by fishermen who had caught and kept a muskie and wanted to contribute to the management of their favorite species. The bone is part of the shoulder of the fish. You can see where it comes from right here. And with it, like I described earlier, you can tell how old the fish is, how old it grew each year, and you can then look at whether warm or cold springs produce more muskellunge, or whether warm or cold summers are better for growing big muskellunge, and other things like that. These are a pretty special fish, and the people who fish for them love them, so it's one of the species Ontario makes sure we look after really well. The oldest muskellunge we had was a 35-year-old male from the St. Lawrence River, and the oldest female we ever had was this fish right here. She was 30 years old. She's the largest muskellunge that's ever been recorded and weighed properly, and she was caught in Ontario. She was born in 1958 and caught in 1988. Later, I was a biologist for the province, working on streams along Lake Ontario, and I spent a little time working on walleye in different parts of Ontario, and then at last from there I moved on to the OFEH. I first started here as a fisheries research biologist, doing a lot of the same things I had done for the province, looking at how old fish were, how fast they grew, and what that meant for the health of populations. And then, just over 15 years ago, the chance came to work on an important conservation project, Atlantic Salmon, and that pretty much completed the circle for me. So thank you for listening and watching, and if you have any questions, please pass them along to Ben, and he'll get my answers back to you shortly.
Hello everybody. Thanks for tuning in to this week's segment of Fishy Facts. I'm Johnny Nene. And this week, I'm going to talk to you about an exotic fish from Africa, the African lungfish. The African lungfish is native to Middle and West Africa, as well as the northern part of South Africa. Their habitat consists of submerged plant cover along riverbanks and lakes. They have small, beady eyes, a prominent snout, and 2 pairs of long, filamentous fins, which they use to help them crawl along the mud during the dry season. Their back and sides are olive brown in color, with blackish or brownish spots on their body and fins. They can reach lengths of up to 1 meter long. African lungfish are omnivorous, and they have been known to eat a wide variety of food items, including tree roots and seeds, mollusks and crustaceans, frogs, small fish, and even members of their own species. Lungfish spawn during the onset of the rainy season. Females will lay their eggs in nests that are built in weedy areas. Males will guard the young for up to 2 months. The young, or larvae, have external gills, similar to a mud puppy or an axolotl, and they are slowly absorbed as they metamorphosize into adults. Lungfish are sometimes referred to as living fossils because they have survived unchanged for nearly 400 million years. They have unique adaptations that allow them to breathe air, which is where their name comes from. Lungfish will suck air from just above the surface of the water roughly every 30 minutes. During the dry season, as rivers and lakes begin to dry up, the lungfish burrows into the muddy bottom of a river or lake bed. Once it has burrowed into the mud, the lungfish encases itself in a cocoon of mucus, which helps trap in moisture, and then it enters a state called estivation, similar to hibernation. In this state, the lungfish survives by extracting nutrients from the muscle tissue in its tail, and it can survive in this state for up to 4 years. The lungfish resurfaces again once the rainy season arrives. Well, I hope you guys enjoyed learning about the lungfish in this week's segment. Be sure to check out next week's segment, where I'll have some more cool, fishy facts for you guys to learn about. Thanks, everyone.
Thank you, Chris and Johnny, for those informative presentations. In our next episode, we're going to learn what Atlantic salmon eat and what eats them. Until then, keep on swimming upstream.